Hi, we are engineering brothers. In our previous consideration, we have taken this first transfer function over here, and we have already considered whether the system is stable or not. And let us just go for our next transfer function, which is this one over here. So let us just remove those points over there, because just by looking at our S plane, we are going to comment on our considered system, that whether the system is stable or not, then we can comment on that. Now let us just say, in this case, our transfer function will be quite naturally this one. Our next transfer function will be 8 s minus 2, this one will be s plus 1 s square plus 4. Now quite evidently you can see that if you just make the denominator that will be equal to 0, we are having the plots for our pole locations over there, and according to that pole location we can comment on our S plane, or we can comment the exact stability of our system, whether the system is stable or not, we can say that. Now for our poles, we are having our S plus 1 multiplied by s squared plus 4 equal to 0, which actually give us the first plotting point of S1, that will be is equal to minus 1, and we can say that for our s squared plus 4 equal to 0, we can write this equation as s plus j2 s minus j2 over here. And according to our formulation of our s square minus of b square, we are having this will be our formulation, which is quite naturally s square plus 4, that will be equal to 0, which actually do give us the formulation, that is s square plus 4 equal to 0. And for these are our poles, or location of our poles, and this is quite naturally our complex conjugate poles, which are placed at our j omega axis over there, which I'm just going to show you over here. And for our zeros, we are having our points, that is quite naturally s minus 2 equal to 0, and the location of our 0 will be s is equal to 2 over here. Now quite naturally a solution for our considered poles are, this one will be s2, that is our minus j2 for this one, and s3 will be our plus j2 over here. Okay, now let us just plot those points in our S plane, and after that we can comment our system, whether our systems are stable or not. Now at our minus 1, we are having our poles over here. Now at this point we are having our poles of minus 1 over here. In our next considered point, that are being placed over here as our plus of j2, say this one will be our plus of j2, and this one will be our minus j2 over here. Okay, and our zeros are placed at our plus 2 point over there. Now the zeros are placed at this point over here. Now we are not interested about those zeros, though the zeros are placed at our right hand side of our S plane, but we are not interested about that locations of our zeros over there. We are only interested about our locations of our poles over there, which are placed one poles are located at our minus 1 point over there, and our complex conjugate poles are located at our plus of j2 and minus of j2 over there. And as these two poles are placed at our j omega axis, and for that one the number of poles are dominating over here. Why do I consider these poles are dominating? Because you can see that are placed at our j omega axis over there, and that is why we can say that that plus of j2 and minus j2 are dominating poles over our for our transfer function over here. Now these dominating poles do have the maximum number of effect to consider or to have the system as our stable or unstable system over there. Now, according to the position of our dominating poles, which are in this case is J2 and minus J2 over here, and according to the location of our these two dominating poles of our J2 and minus J2 pole, we can say that the said system will be marginally stable. Why marginally stable? Because you can see that these poles are placed at our j omega axis, and because of that, as these two poles are dominating in nature, and once again these two poles are placed at our j omega axis over here, then we can say that the said system or the transfer function of our part 2 or this Roman 2 will be considered as our marginally stable system over here. I hope you have totally understood up to this one. If you still have any doubts, please let us know in the comment section. For better understanding, do like, do share our videos and keep following our channel. In our next class, we are just going to focus on this next transfer function over here. That's it. Thank you and goodbye.
If you like my video, so what are you waiting for? Please do subscribe my channel, hit the bell icon for more updates and stay tuned to the channel. Thank you and goodbye.